Okay, it says that the captain of the hockey team is present at 95%. Okay, so on the tree diagram you see they've put 95 there. Okay, so what we're going to do, we're going to put 0.95 there. Now, obviously, on a tree diagram, immediately you can now say, right, well that means that that's going to be 0.05 because each section is going to add up to 1. So these little pair here are going to add up to 1 and these pair are adding up to 1 as well. Now it says the vice captain of the team is present at the assembly 93% of the time that the captain is present. So if the captain's present, the vice captain is also present, so that's 0.93. Okay? And so that must be 0.07 because those two add up to 1. But it says if the captain is absent, then the vice captain is only present 75% of the time, so that's 0.75 and that's 0.25. Now that was present, not present, present, not present, present, not present. Okay? So just get the idea of the fact that you've got to get this tree diagram filled in correctly. And if you get the hang of this, it's fine. Now do you remember that when we go along a tree diagram, we multiply. Now although the question actually only asks for the top one, I'm going to do them all because I figure there's going to be a part B and a part C. Okay, so let's do that then. So on my calculator, I'm going to type in 0.95 times by 0.93. And I get 0.8835. Okay? Sorry about my dodgy threes. Please don't send me messages on YouTube saying that my writing's terrible. I know it is, I'm dyslexic. Okay? So then the next one is 0.95 times by 0.07, which is 0.0665. Then this one is going to be 0.05 times 0.75. So this is 0.0375. And this last one is 0.05 times by 0.25, which I think is going to be 125, yeah. So that's 0.0125. Okay? So there you are. I filled all my numbers in. Now, you could do that yourself. That's quite easy. Just remember that when you're going along the lines of a tree diagram, you multiply. Okay, now, so I've got my tree diagram all filled in. Now the question said, calculate the probability that both captain and vice captain will be present. So the answer to this particular question here is going to be 0.8835. So part 1, the probability that both present. You don't have to. I'm doing it because I'm being recorded. Okay? If you'd just written that particular answer down, that would be fine. All right? A lot of people worry about where the working out came from. The working out came from the tree diagram. All right? Now, the next thing says, calculate the probability that the award will be presented at the assembly. So, in other words, under which circumstances on my tree diagram would you get the trophy? Well, you get that one because they're both there, so the captain goes up and gets the trophy. Yeah? Would you get it with this one? Yes, you would, because the captain's present. So it doesn't matter that the vice captain's not present, the captain gets it. So yes, you can have that one. The captain's not present, but the vice captain is present, so you get that one. The captain's not there, the vice captain's not there, do they get the trophy? No. So it's only that one that doesn't count. So I have to add those three together. Okay? So I would write down for my working out for part B, I would actually write down 0.8835 plus 0.0665 plus 0.0375. Now there is a quicker way to do it, but I'm not going to show it to you right now. I don't think we need to worry about that. Why is it really important, Liam, to write down all those three numbers?
So it's easier.
Number one, it makes sure that you don't forget what to do. And the other bit is that if you happen to make a stuff up on your calculator, when it happens, especially with lots of zeros and stuff, yeah, you could actually get a minor error ignored or a calculator error ignored. Yeah. But if you get in the habit of writing down what you're going to type into your calculator before you start, but if you're like me, I press buttons wrong. So that's the answer to the question. Okay? Now we get to this bit. If the vice captain of the hockey team is absent, there is a 40% chance that he is sick. If the captain is absent, what's the probability that the vice captain is also absent and is not sick? Wow. That's a complicated one, isn't it? And we'll come back to that in the next video.